Okay, so let's get started. So now, yeah, let's take a look at this program. So the program that we are working on, CP21A. So more insertion sort. So this is the code that we were looking at in the last class. So now we will change these codes and organize it. Let's see how many lines this code is. WGC minus L. It's around 150 lines program. Okay. So we will reorganize this code so that it will be so that we will learn how to handle large projects, large programs. Okay, mkdir insertion sort. Okay, now CP insertion sort dot C to insertion sort, CD insertion sort. So now let's open this. Open folder. No. All right. So we would like to reorganize this code. We would like to reorganize this code. First thing we would like to do is we would like to have all these functions, you know, all these functions in a helper in a helper file okay. So let's see. So we have allocate node, free node, insert node, delete node, all these functions, search node, print list, except main. So all this code, we keep it in a file called as helper.c. And then, so we create a new, and then you see that the node dot, this is not, it is undefined because this is defined here. This is defined here. So what we do here is, so we create a new file. We create a file called as node.h. And in node.h, what we have is we will copy this one, node.h. And so in the main here, so .h is all declarations, etc. So we put them in a .h file. It's not directly compiled, it's just included. Okay. So now node.h. So here we need stdio.h, and now here we include node.h. See, now all the errors will go away. Did you see how in helper.c, if we comment this out, you see the type node is not recognized. But if I uncomment this, and you see that all the errors go away, because now the contents of node.h are included, textually included in this code. We cannot, so when we use this one, what happens is instead of this, if you use this, then the compiler will search for node.h in some standard paths. Okay, I don't know whether node.h is, but usually when we use this, Latest semantics of C99, I don't know, but if you use this, it looks for node.h in the local directory. Are you with me? When we use double quotes, the header file is looked for in the local directory, whereas stdio.h, stdlib.h, they are present in some place like slash user include, like for example, name. Yeah. So usually it will go and check the standard paths for you can do that. It's not a library, it's just an include file, std, or let's see if there is something like node.h. Yeah, it is from some other places. This is not the same node.h anyway. So the header, when you use node.h within quotes, it tries to look for it in the local directory. Okay. So now we want to compile this code. Now, when you try to compile insertion sort.c, what will happen? GCC insertion sort.c. It complains that print list, delete node, all the functions that we are using, they are not defined because the definitions of these functions are not available. They are not defined. Okay. Are you all with me here? That but if you give this thing in GCC insertion sort.c and helper.c together, then you will see an a.out coming. If you give these two files together, then an a.out has been generated. What happened? Okay, let's see what happened. Oh, that is because we have to give keys.txt. That's what will happen if you don't write your program in a user-friendly manner. So it is working. Okay. Are you all with me here? In order to compile a multi-file program, we just have to give GCC all the .c files together, and we don't need to give the .h files at the compilation. Yes, no? Right? And then you see there is a warning that insert node, print list, delete node functions that you are using here. I don't know their types. Okay, I don't know their types. So I am assuming, since you are calling insert node with an integer, I am assuming that the parameter type for insert node, it is an integer and there is only one parameter. And print list doesn't, you are not passing any parameter to print list. So, we don't include .c files. And then in print list, you are, you are calling print list without any parameters. So I'm assuming that the print list parameter type is empty. Okay. Also, just want to do one experiment before we move further. Yeah. Same. Okay. So, do you understand this warning? Implicit declaration of the function insert node. That's the Okay. How is right now? See, Amoga, we are see, right? If you see the code organization, you can clearly see that your main all these no allocate node, free node, insert node, all these things, they are not. They are just like helper functions. So when you are writing a big program, you want to put all your helper functions in one place, and then there is another place where you are doing, like for example, in the insertion.c in the main file. In the main file, you can focus on some other application logic. Okay, there are, when you write the complex software, there are so many things that will be part of the software. You don't want to put everything together in one file. You want to logically organize them. Okay, so that is the reason why we want to use this. So now you can see in your main, you can only just focus on the core thing, and this helper.c, and you clearly nicely debug it and keep it aside, and it is out of your way, and you can work on the core programming application logic. So one way of doing this is, so you can keep print list. What is the signature of print list? Void print list void. Okay, so you are putting the signature of the print list function, and when you compile it now, that print list there is no longer you are telling the compiler the type, the function type prototype. It's like this. It takes no parameters, hence it is void, and it returns nothing, hence it is return type is also void. Why did you use key.text? Once much you forgot. We are compiling this. What are we doing here? The data file. Key.text is the data file in which we are doing an see line number 13 and 14. And similarly, what is the type of insert node? What's the type of insert node? Insert node is insert node and delete node. Insert. We can have insert node. Node.h, it just contains the declaration for the node. That's all. And that this node.h is included in helper.c on line number 4. Okay, so now you can see, if I compile now, then the warning associated with insert node is gone. And in fact, we don't need to give the parameter, that key and all. We just need to specify that type. It will still work. Okay. Similarly, delete node, void delete node, int. That's it. Are you all with me? We didn't include helper.c. No, but what happens is the way good question, Srija. So I will tell the process. Okay. Yeah. So Srija has a good question. I will give an elaborate answer. But at this point, so the important thing is we are making these, we are specifying these prototypes. Okay, so that the compiler will know that the type of a function, that is, what are the return value of the type of a function includes what is the return type of the function, and what are the parameters, and what is the type of the parameters. Are you all with me so far till this point? Till this point, you're all good? Okay. Well, one interesting thing, while typing in terminal, does the order of passing the .c files matter? I'm not sure, Pawan. I just have to check once. Okay, there is some. Okay, good. Yeah. So one important thing here is what is the scope of these functions? What is the scope of these functions? The scope of these functions is across all files. The scope of all these functions is all files. Okay. And also not only that, like, like for example, we are declaring head here, and so we can access head from, let's check if we can access head from here. If head is equal to null, see, you can see printf linked list appropriately initialize to be okay. Otherwise, if it's not equal to empty, printf something wrong with the linked list. Exit. Are you with me on the code on line 20 from the new if code that we have written? Are you all with me here? So you can already see when we compile, there will be a problem. Head is not, head is not recognized. The variable head, sorry. Either way, it doesn't, at least at this point so far, it is. So while functions are available, while the functions that are defined in helper.c, while they are available for in the insertion sort.c, that is the main.c, perhaps I would like to rename this. Okay, rename it as main.c. Okay, so in main.c, the variable head that is declared here, it is not available. Okay, in order to do this, what we can do is, in order to say extern node star head, if we do, then what happens is, that means, hey, you know what, I am using head in this program, but head is available in helper in some other file. That is the information you pass on to the compiler when you use the word extern. But the problem is, when we use external node star, then the issue becomes the type def node is not defined here. So we have to include what? Have to include node.h. Are you all with me here? What we did here on line number 10, since we are using head here, and head is defined elsewhere, and when compiler looks at head, like for example, if I comment this out, and when compiler looks at head, then compiler thinks, hey, I'm encountering this variable head, but it's not defined anywhere here. Then it becomes an issue. Okay, so in order to solve this problem, we are giving a hint to the compiler on line number 10 that the variable head is declared elsewhere. It is declared elsewhere, and this elsewhere happens to be helper.c now. Okay, now let's run this program and see what happens. Okay. Linked list appropriately initialized to be empty. Do you see what is happening here? You're all with me? No, the head is also actually across all files. The scope of head is also all files. Okay, but the only thing is for the variable, we have to explicitly tell the compiler that it is declared somewhere else by using the extern function. The scope of head and all these things, it is globally available across all. Okay. But what we need to tell the compiler with respect to variables is by using the extern statement on line number 10, we are telling the compiler that the variable head that we are using in this file, in this C file, it is being declared somewhere else. Are you with me here? Extern, the use of extern. And if you want to, but then you say, I want to restrict the scope of head to only helper.c, and if we keep a static keyword there, then the scope of the global variable head, it will be restricted to the helper.c file only. And in this case, when you try to compile, then you have this error. Now head is no longer accessible for main.c because we made head into a static global variable. Okay, question for all of you. What is the scope of any global variable? What is the scope of any global variable? No, that is lifetime program run. I'm not talking about lifetime of the global variable. I'm talking about the scope. The scope of a global variable is all files, across all files. If you want to restrict the scope of a global variable to one file, what should we do? We should put static keyword before it. Right now, in this particular program, it perfectly makes sense to make this thing into a static, because this is a kind of, I just wanted to show something here. So because of that, I used head in the main, because otherwise when you are working with a linked list, you don't care what is the variable you use it to point to the beginning of the linked list. All those things you are not aware. So the way that we wrote the code on line number 19 to line number 27, it doesn't, it's not the way to do it. No, we don't do that. Okay. So the right thing to do in this program is to completely isolate the code for the linked list by making this head as a local variable, but still we won't expose all these functions. Okay. And also perhaps you may want to make allocate node and free node. They are we want their scope to be restricted to this file only, because those are helper functions used by the linked list code. But whereas insert node, delete node, search node, we want other people to see it. Are you with me here? Why we want to make 9 and 20 allocate node and free node? Why do we want to make them static? When we make them static, then that means the scope of these functions is restricted to only this file. Are you with me? Why do we want to restrict them to only this file? Why do we want to restrict free node and allocate node and free node to be restricted to only this particular file? Yeah, because we don't want them to expose to the outside world. Allocate node, free node, they are helper functions used by the linked list program. So you don't want to expose them to the outside world. So you want to make them static. But if you make insert node static, what happens? If you need insert node static, then then what happens is main.c will not be able to call insert node and it will create a problem. And we don't want to make insert node static because we want to, we want the outside world to talk with the linked list program through this insert node function. Are you all with me so far? All good? So now one more thing we can do. These three things, you can make it part of this so that you are good. So if you see now the function prototypes, we included it in node.h and that's it. So now, so this is a very clean way of doing it. So in main.c, we have the main program. In helper.c, we have all the helper functions. And in node.h, technically speaking, you can add anything in node.h. The text of it will just be included. And then in node.h, we have this node definition and all these function prototypes. Are you all with me here? How to write these multi-file programs? We used one header file. We used main.c, helper.c, and the way we compile. Yeah, you can add in insert node and delete node also. In anything you can add in .h file, but logically it doesn't make sense. Okay. We have to, when we include, the whole thing will be included. Yeah, you can have helper.h also. Yeah, it's true. Instead of helper.c, you can have helper.h also. It's possible. Okay. So now I tell a question asked by Amoga. So what actually happens is, see this GCC, the way things happen is when in main, let's say when print list or delete node or earlier when the head variable is used, the compiler doesn't know the address of these variables to use, the address of the functions or the address of the variables to use. So what happens is that main.c, from main.c, a main.o file will be created. Pay attention. Okay. So this is, what's the question asked by Amoga again? I forgot. But this is the answer, but I forgot the question. So an object file will be created. Similarly, pen not visible. Okay, now it should be visible. Similarly, main.c, so I'll answer your question also, Harshvardhan. So similarly, what is the other thing? Helper.c is compiled to helper.o. O is an object file. This is not ready for execution. Main.o, helper.o, they are not ready for execution. In main.o, if you go and look at the code, in main.o, if you go and see wherever header is used, wherever head variable is used, that will be kind of there will be a slot created and that will be empty. because the compiler doesn't know the address of the variable head. Okay. So later on, what happens is these helper.o and main.o, they will be passed to the linker and also the libraries. Okay. Like for example, whatever the libraries that we are using, so all those things, they will be given to the linker libraries, standard libraries, and any other libraries that we use. And all these things will be given to the linker, and the linker will generate this A dot. So when the linker, what it does is, wherever head is used, it goes and looks at helper.o and it figures out the address of the head and it fills it in appropriately. Are you with me here? Yes, no? So this is a two compilation, but when you give the command gcc main.c, and all this is internally done by gcc. If you just give gcc main.c helper.c, what internally happens is gcc first compiles main.c to main.o. This is step one. Let me use a different color. Yeah, maybe I can use this. This is step one. This is step two. Step three is the linking process. So all these things will be linked by the linker, and an executable is generated. The interesting thing here is, let's say if you modify helper.c, then you can only generate an object file for helper.o and then do the linking part. And that's what happens for standard libraries, right? Standard libraries are compiled long time back, and you don't compile them again. You just use them in the linking process. Does this make sense? And the advantage with this approach is, let's say you are building a huge software, like for example, a Linux kernel or GCC compiler or any big software. Any big software, it will contain, let's say, some 10,000 files. Okay, and each of them from f1.c, f1.o will be created, from f10,000 whatever, f10,000.o will be created, and you link all of them and you generate an executable a.out. Okay. So the one of you asked the question, why can't we include everything? So when you include everything, what happens is, let's say Sananya is introducing a new some flight passing by. So let's say Ananya is working on some feature which is there in F20. Like for example, in F20.c file, right now we are linked list program is, we are using linked list to realize a dictionary data structure. And then she learned about trees, and then she figured out, why are we using linked list to solve this problem? Let me use trees. So she wants to revamp the code, but no. So when she modifies this program, all she has to do is she will only generate f20.o and then do the linking process alone to generate the whole executable. On the contrary, if you just include everything, like for example, you have a big you have something like main.c. If you have main.c, in which you do, what do? You include hash include f1.c, f2.c, f10,000.c. Then what happens is you put all source code together and you compile. The compilation time, it just blows up. Okay, it will take instead of being able to compile your program in 5 minutes, you will take maybe 5 days to compile your program. That's number one. Number two is like, for example, Ananya could be using some insert node insert node function, and someone else could also be using the same function. Let's say in f2.c, someone else is also using insert node. So now you will have a namespace collision. This namespace collision Ananya can avoid by making this simply a static. But if you do this include everything, then we cannot avoid that namespace collision. Are you all with me here? Does it make sense? What are the two big reasons why we want to use, just don't want to blindly include all C files together? What is the first reason I gave? Compilation time. Compilation time is very important because you don't believe right now when you compile, it just comes to you like that. When you work on big software, when you give a compilation command, it will take 1 hour, 2 hours, 3 hours, etc. Okay, it will take half a day. So compilation time is very important. So you want to reduce compilation time. So that's two reasons. Among one reason is compilation time. Let me use this color. Reduce compilation time. Overall you just say build time. This process is called as a build, reduce build time. What is the second reason? Namespace collision. Excellent. We want to avoid namespace collisions. Okay. If required, we can declare 2 or more kinds of parameters inside a function. Yeah, we can do. Yes, Gnan Prakash, no problem. Okay. So now let's try to. So the way I told the story, it doesn't pan out if we just do this f2.c so on up to f10,000.c, then GCC will blindly compile all the 10,000 files. So in order to make use of the fact that we are only modifying f2.c and we don't need to, hence we want to compile only f2.c, but not anything else. We need to know how to write what are called as Makefiles. Okay, so now let's see how to write a Makefile. I have some sample Makefile. Before, I will just copy it from here and okay. So in the Makefile, so on line number 6, we are using this. I think this is a macro where we are telling that we are using GCC as a compiler and we want to compile our programs using these flags. This is what we did. And then, so here, yeah, let's call our program as mysort. And so here, mysort depends on main.o and helper.o because our program is present in main.c and helper.c. In order to generate mysort, we need two object files. One is main.o and helper.o. And once these two object files are available, then we generate this executable mysort using using this command. Okay, GCC using these flags, you generate -o mysort means generate the executable mysort. And the rest of the two object files that you have to link, this is where the linking is happening, is main.o and helper.o. Okay, And main.4, it depends on two files, main.c and node.h. Okay. And and then helper.o is dependent on again on helper.c and node.h. Okay. So now what happens is when we give make my sort, okay, so when we say make my sort, then this my sort executable is created. Okay. So what happens here is the recipe for construction. What we are doing here in this make file is we are telling the make program, make is a program. We are telling the make program that in order to create the recipe for creating my sort executable, it consists of the ingredients, the necessary ingredients are main.o. The necessary ingredients are main.o and helper.o. And once you have these necessary ingredients, the way you are going to compose them together, I am using the way you are going to compose them together to prepare to generate my sort is the command that is given on line number 13. Line number 13. Are you with me here? That my sort, in order to prepare my sort, these are the ingredients required, main.o and helper.o. How do we use those ingredients to generate my sort? That is given on line number 30. Are you okay with this one? Line 12 and line 13, are you okay? Yeah, the class is becoming sluggish. I can see that you're all tired as the semester is coming to an end. And in order to generate main.o, there are two ingredients. One is main.c and node.h. And the recipe for composing main.o from main.c and node.h is given on line number 16. Line number 16. And on line 18 says the recipe for creating helper.o is node.h. It is node.h. Let me use this. This is node.h. And the other file that is required is helper.c. And the way to compose this to generate helper.o is is given on line 19. So the make program, it looks at this make file and construct this what is called as a directed acyclic graph. Directed acyclic graph. DAG. So now what happens is when you modify main, let's say when main gets modified, then main.o also will be modified. And when main.o is modified, then my sort also gets modified. So what happens in that case is only line number 16 and line number 13 will be executed to create the new my sort. And line number 19 will not be executed because helper.c didn't change. Because of that, helper.o didn't change. So we don't need to execute line number 19. Because the way, because .h files don't need to be given on the command line. So the compiler will look into the program and just include them. Hash include, because you are including them, node.h. Node.h is not separately compiled. It is textually included in main.c. Node.h is not separately compiled. It is textually included in main.c. Are you all with me here on this one? On this DAG structure? Can you give me the modification to which file makes both all line 13, line 16 and line 19 to be modified? the modification of which file. Yeah, so when node.h gets modified, I'm using a green color. When node.h gets modified, then no, it will impact main.o, it will impact helper.o. So line 16 and line 19 will be executed. And then it will also impact my sort.c. Because of that, line 13 will also be executed. That's true. So for compiler, the text of node.h is as good as present in .c file. Are you all with me here? Why we don't want everything as .h file? Because unnecessarily you will end up compiling again and again and again. If you have 1,000 files, if you put everything as a .h, and if you include everything, then all code, some million lines of code will be compiled every time. You want to compile million lines of code for every small change that you make? Like for example, let's say on PowerPoint, you want to support Telugu language, no, or some language. The whole of the code base remains the same. Only a small part where the Telugu language support is present, that will change. So you just have to link that part. Instead, if you put everything together as a source code, then you have to compile million lines of PowerPoint source code, and it will take perhaps a day or 2 days to compile it. Okay. Do you completely understand this DAG structure? This is the essence. This is the essence of the whole. And you have a target here. This is what is called as a target. My sort is a target, main.o is a target, helper.o is a target, clean is a target. And my sort, the target that is there on the first line, it is a default target. It is a default target. Now, like for example, if I do, let's Control L, if I do make, then it doesn't do anything because it knows none of there is no need for all the source codes remain the same. So make says my sort is updates. I don't need to do anything. Are you able to see it? And on the contrary, let's go and just for the sake of fun, let's say I just change the timestamp on main.c and oh, what happened? My keyboard is not working. Don't know what is happening. My keyboard not working suddenly. Lose connection. How can suddenly lose connection? Did I type something interesting? Keyboard caps lock. Yeah, it's no caps lock is coming and going. So that means the keyboard connection is not a problem. It is. Did I reopen terminal? Yeah, maybe I will do that. Yeah, thank you. I think something to do with my screen. Okay, then. Yeah. So it's a good advice. Some terminal hang happened. So now when we do make CP insertion sort, make looks by default for Makefile. Why main.c is modified? Yeah. See, now I did small change in the. I didn't do any change. I just went to main.c, inserted a blank, and then I just went and did a make. And the Makefile figured out that the only thing that changed from the last is main.c, and it compiled only main.c. I think it uses the timestamp of main.c. Good question, Ayan. I was also thinking, but where is the timestamp? How does it know that the timestamp changed since it last compiled? Oh, I think it will just look at main.o timestamp and main.c timestamp. If the main.c timestamp is greater than main.o, it will compile. You understood? Main.c and main.o are there. If the main.c timestamp is greater than main.o, then it will figure out that main.c is the latest version and it will compile. Okay. So now with this, with today's lecture, it's you reached a very important milestone in building large programs. So few things I would like. There are when you build large programs, few things that you need to know is one is Makefiles. This macro processor or preprocessor, that's important. We didn't use it, the full power of it. In the next class, we will look into it. Number 3 is version control. See, for all of you guys to become pros in programming, these 3 things are important to learn. Makefiles, version control, and preprocessor. In the next class, I will talk about the preprocessor, but version control, I will give you one video link. I would like you to watch that video. Okay. So that's it. So that's the, yeah, Git is the most popular. Oh, Valgrind is, it's not part of it, but we have to talk about memory leaks. I'll talk about memory leaks. Yeah, this week I'll talk about memory leaks. So Friday class, memory leak class. Friday, I will talk about Valgrind. What is OH? Quiz 2 discussion, theory discussion. I will do it Parth. Let's try to finish today. Today is about Makefiles. Thursday, OH is office hours. So Thursday is preprocessor deep dive, and version control on your own. And Friday, Valgrind. And in the next week, I will, with that, in some sense, we, the whole thing is covered. And in the next class, what do we do? And in the next week, I will discuss quiz 1 and quiz 2, quiz papers, quiz and midsem next week. You were taught Friday, Saturday, this week onwards, I will not be able to take Saturday class. I will take Friday 2 to 3. So that's the reason. So about today's office hours is going to be interesting. So in honor of Valentine's Day, we will study a problem called as stable marriages problem. And hoping that you will soon come to campus. Along with stable marriages problem, we will study stable roommates problem. Okay, so the plan for today, two things we will look at: stable marriages and stable roommates. Okay, so in office hours, not they are all time pass.